All right, Friday night, time for an evidence-based triathlete, and we've got co-host Jim Martin because Ted Jard is still laid up. He's recovering from some surgery. We miss Ted tremendously and send our kind thoughts his way to get better. Maybe we'll have him back next week. But in the meantime, we've got our bike specialist, Dr. Jim Martin. What's happening, Jim?
Uh, you know, Summer's coming to an end. It's almost over, and I don't know how I missed it. Uh,
When do you guys start class?
Monday.
Oh, oh, so you're a week ahead of us. We'll start the next week. So, yeah, everyone's coming back and starting meetings. So all the meetings are being jammed in this first week. So,
I had to sit through some this morning. Yes, it's
yeah.
always pleasant.
Oh, good. So you're getting a little rain up there too right now, you said.
Not quite yet. It's
Oh,
very threatening, but
yeah.
yeah, and you're a lot is on your way, right?
Yeah, we apparently have some hurricane that's coming up through the Pacific over San Diego and headed this way apparently. So we'll see. We'll see how
Yikes.
that works out. Did you get a ride in this week? A couple rides?
Oh yeah. Well, let's see. A week ago was my birthday, and so I did sort
Oh,
of a special ride. It's 35 miles, but it's about 5,200 feet of climbing.
oh, that's
So
great.
so it's a good way to celebrate.
Yeah, yeah. No, that is. I saw that ride on Strava. Very impressive.
Well, it's not impressive because I have small gears and I don't go fast.
That's right. Well, what chain rings do you have on that?
Yeah, round for me.
What's that? Oh, round for you.
Round.
Yeah, yeah, yeah. So tonight we're going to talk about chain rings, and we came up this topic because Jim has done some work in this area and has some really neat papers that are published on uh, oval chain rings and looking both metabolically as well. And then the other paper you have is on max power and oval chain rings. Now, I'm going to date myself a little bit, but I had some of the first oval chain rings back in the 80s, Shimano Biopace, I think it was. And that was the rage back then. And then it seemed to just go away. And then it seemed to come back, what, maybe 10, 15 years ago, maybe? Or I'm not too sure of the history, but they're still around.
Oh yeah, yeah, yeah. There and there are devoted followers for sure.
Yeah, yeah. So the idea of an oval chain ring seems logical that you're trying to increase your leverage, but it's also something I've heard you say before is that the pedal still goes around in a circle. Uh,
Yeah, it actually doesn't increase your leverage. It decreases it during the leg extension phase.
okay.
So you effectively have a larger gear ratio when you're extending your leg.
Hmm.
And the theory is that if you can spend, so you put a bigger gear, so you slow down the crank rotation, so you spend more time in that leg extension phase, then that's where you produce the power. And so overall, your power will be increased. What they don't seem to understand is that when you slow down this, you also slow down this
Hmm.
because the cranks are coupled. So whatever goes down goes up.
Yeah, yeah.
And yeah, so they're they're trying to elongate the extension phase, but you can't do it with coupled cranks. Now, interestingly, this is an aside, and you know I spend a lot of my time thinking more about maximal power than
Yeah.
endurance, but with regular round chain rings, when people sprint, and it's not just me, it's not some fancy technique, it's cyclists that come into our lab, and this will be a little bit mind-blowing, because of your ankling action,
Hmm.
because you tend to come over the top dorsiflexed, and then at the bottom you're plantar flexed,
Hmm.
you actually spend more time in the leg extension phase than in the leg flexion phase.
Hmm.
You tend to extend for around 190-ish. And so then you flex for 170-ish.
Okay. In terms of the angle of the pedal stroke.
Yeah, I'm sorry,
Yep.
degrees,
Yeah, yeah.
100,
Mm-hmm.
190 degrees of extension and then only 170 of flexion
Mm-hmm.
for
Mm-hmm.
the whole leg. And that's because of the flexibility of your ankle.
Oh, interesting. Yeah, that's so cool. So maybe let's just back up a little bit. How did you even get into looking at oval chain rings? Were you an adopter as a cyclist first, and then you said, I'm interested in this, or did you look at it from a research end?
Well, always from a research. No, I never wrote them myself. Um, I can't actually remember what the original, it may have been that just somebody called us. I truly don't remember.
Hmm.
Chi Hoi could maybe tell you. It was his. So Chi Hoi Leong is at uh, Connecticut State, and so these are his papers.
Mm-hmm.
Um, should have looped him in. I don't remember how we got on the topic.
Hmm. Oh, interesting. So, but you've worked with these for some time. Okay, so sorry, you're explaining the mechanics and the idea behind an oval chain ring.
Yeah, what they're trying to accomplish. Yeah, now what they do is a little bit different. So,
Well, maybe
um,
we'll jump right into that. So you've done some work in this. So what is your research? What are some of the projects that you've done?
yeah, so really, Chi Hoi's dissertation was three really nice studies. One, he got the whole power cadence relationship during sprinting.
Hmm.
So it's a parabolic with an optimal somewhere around 120-ish RPM, and so we wanted to get the whole power cadence relationship, and we had round and then two oval chain rings, um, rotor and asymmetric.
Hmm.
So smaller eccentricity for the rotor and larger for the OSIM. And there was no difference in the max power, so the apex of the parabolic relationship. There was a tendency for the oval chain rings to produce less power at the high cadences, but nothing significant.
Hmm.
Um, so that was the first one. And then we moved over to the biomechanics side of the lab, and we did. So we saw they didn't work,
Hmm.
and we wanted to understand why they didn't. And the cool thing about Chi Hoi having done this study is he didn't even own a bike. He's got no dog in the fight on chain rings. In fact, he's a rock climber. He's a 514 climber. So
Oh, interesting.
way,
Yeah.
yeah. He's amazing.
Yeah.
Um,
Yeah.
and anyway, so we did our best to blind the subjects to these, because the previous results were mixed. Most of the studies show no improvement, no change. A couple show improvement, but they have some dicey methods, so I won't go into that. But we didn't want to be the case where we said, these are oval chain rings and we think they're going to make you more powerful or more efficient or whatever. No placebo. So we actually built a little plywood wooden box around so that they couldn't see the chain ring.
I love it.
They could feel it, but actually part of the study was, after they had done their 5-minute warm up, we asked them which crank they were on or chain ring they were on, and nobody 50-50 on round versus rotor. So they couldn't tell at all. They were guessing.
Interesting. So
And
I'm just curious, did you have two bikes set up next to each other, or how quickly were you able to change them out for?
oh no, it was the testing was one day on each ring.
Okay, okay. All right, good, good. Yeah, thank you. Yeah. No,
Yeah.
that's interesting that they're 50-50 in terms of whether or not they could determine which type of chain rings they had.
Well, they could tell when they started pedaling that first pedal stroke or two,
Hmm.
but after 5 minutes they had forgotten and they couldn't. Now most of I think they could tell that they were on OSIM 80% of the time,
Okay.
but even there 20 1/5 of the time they couldn't tell.
Hmm.
Um, Anyway, so we did our best to blind it. I mean, you can't blind the feel, but we did what we could. And on the biomechanics erg, we did maximal all-out sprinting, and we also did submaximal cycling at 30, 60, and 90% of lactate threshold. So as long as you're below lactate threshold, you can make metabolic calculations and calculate efficiency. And so that's why we were doing those intensities. And let's see, well, I mean, this is going to be a very short conversation, I think. Well, maybe not. The maximum sprinting is actually really interesting. This is my favorite outcome from the whole thing. So no difference in power, but so why wasn't there any difference in power? And so don't think about cycling as your leg. Think about it as your hip doing something and your knee doing something and your ankle doing something, because that's how I think about it. And so the pedal is slowing down and speeding up because of the chain ring, and we have the data to show that it actually does do that. But when they were doing all-out sprinting, remember I told you that you already do this, you lengthen the extension phase. Well, they defended that action at their knee and their hip. So they changed their ankling action, and you don't have to change it very much because it doesn't change that much. It doesn't change the velocity that much. So they changed their ankling action so that their hip and their knee were identical kinematics. The movement and timing of the hip and the knee were identical.
That's amazing.
It really was. We weren't expecting that. And one of them, I think it might be OSIM. I don't remember which one it is. One of them's got on their website. It takes a little while to get used to. And now in my lab, we say it doesn't take very long at all to get rid of.
Yeah. Interesting. So I want to follow that up just a little bit, because that is super interesting. I mean, there's so many instances. We talked about this even a bit, I think last time we talked, where there's these subtle changes that people make and they don't even know that they're making these subtle changes. In this case, you're saying that the riders adjusted their ankle. I'm sure they weren't doing it consciously at all.
No
And
way.
then, maintaining the hip and knee. They were maintaining the hip and knee power or movement.
Oh yeah, everything about it. The kinematics and the moments, power. I mean, I could bring up the paper and show it. They just overlay each other.
So what is it that, I guess I'm going to ask you this question. What is it about the brain? What is the brain detecting that it's saying, I got to keep the hip and knee power the same?
Oh, I don't know. Something that's evolved over millions of years, spinal cord level motor programs that know what they want, and they know when they're not getting it. And
Oh, I love it. All right. So and I know you've done a lot of work with even just muscle contraction as well. And I guess I got to think that these are big muscles around the hip and the knee more so than at the ankle.
That's right.
Yeah.
But so those are the major power producing actions. First is hip extension, then knee extension, then knee flexion. Anyway, yeah. So that was a really fun finding. And yeah, why, how does your body detect it? Well, you detect things, whether you're conscious of it or not, I guess. The submax was a little different. So with the aerobic or endurance type exercise where we're looking for efficiency, there actually were changes in the kinematics. So the pedal was slowing down and speeding up, and all three joints were as well. So yes, it had an effect. But here's where you have to sort of back up. maybe to John McDaniel's 2000 paper, where we looked at crank lengths from 145 to 195 with cadences from, God, did we go down to 30? No, 60, I think. And when you look at the effect of crank length and pedaling rate, or the combination of the two, you get pedal speed. How fast is the pedal moving around its circle? What we found was that if you look at the metabolic cost, 95% of the metabolic cost across all those conditions, from short cranks at low cadence to long cranks at high cadence, 95% of the variability was accounted for by the power production. How much are we asking them to produce? So only 5% was unaccounted for, and of that 3%, or of that 5%, 3% was accounted for by the speed of the pedal, and that's like a 6-fold range of pedal speeds with those cadences and crank lengths. So now think about so with a 6-fold range of differences in pedal speed, we were able to budge the metabolic cost about 3%. If you look at the non-round chain rings and their eccentricity, they're nowhere near that. They're a tiny percentage, equivalent to about 2 chainring teeth. The perturbation is really small. And so it's not surprising then that there was no measurable difference in metabolic cost or efficiency. In fact, there's a funny story that goes along with this. Chihoy will probably have a different version of it, but when he sent me the email with his first round of data, hey, I got the metabolic cost efficiency here. Here's the figures, and I looked at it, and I can only see one line. And so I just email him back real quick. I don't delete emails. I could probably find this one. And I go, Chihoy, you didn't send me you only sent me one data set. I want to see the other 2 chain rings. He goes, no, they're there. Zoom in and look at the markers.
Yeah.
And so, yes,
Uh-oh. We may have lost Jim there for a second. Let's see if he comes back. Oh, well, there you are. Was that me or you? I don't know.
hard to know.
Yeah.
Oh, it says my connection's unstable, so it was probably me.
All right. So you're talking about a graph where he sent you what looked like one data set.
Yeah, but in fact, and I called him on it. I said, send me the other 2 chain rings. He goes, no, they're all there. And so you zoom in and you realize, oh my God, there's 3 markers right there.
Yeah.
So it's not a case of no statistical difference. It's a case of they're exactly the same.
Interesting. Well, as you're describing that, in another world where I do running research, I put accelerometers on people's heads, and I would put an accelerometer on their legs, and I'd have them run in all different conditions, lots of different subjects, lots of different conditions, like different surfaces, running at different speeds, forcing them to change some part of their gait. And what's really interesting, just like you're describing here, I'd look at all these data sets, and the head impact acceleration is almost the same all the time. Yeah. No matter what the perturbation was that we introduced, different shoes, different surface stiffness, the head acceleration was always staying the same. And so that seemed to be a real critical thing that we think that controls gait, is trying to maintain that stable visual field, which makes sense. But so what was it that made sense once you discovered that there was multiple data sets that?
Well, just that, what I was talking about earlier, that yes, it affects the angular velocities. It does. Now, unlike the sprinting, your leg lets it affect it, but the differences are so small that they don't have any metabolic effect.
Interesting.
And so
So
go ahead.
no, I was just gonna say, so you could, and in the paper that I looked at that I sent you that you did, you looked at chain rings with different oval shapes, and even the different oval shapes, it's so small that they're not really making much of a difference. Could you get to a real extreme shape that you think would influence something?
Yeah, we don't know. I mean, maybe, but I doubt it.
Yeah,
Because again, what goes down comes up.
yeah, yeah.
So you're slowing down the flexion phase as well.
Hmm.
Um, the there's a paper by Rick Neptune it's a modeling paper,
Hmm.
and he, I think, modeled eccentricities up to 30%. So pretty darn big
Hmm.
changes. And there he was seeing, according to the model, a couple of percent.
Hmm.
I don't know that you could get a chain ring like that to actually work on your bike.
Hmm.
So I don't know.
Hmm. And when
But
you're talking about eccentricity, just for everyone, you're talking about how oval the shape is.
that's right. Sorry. Yeah. The ratio of the minor diameter and the major diameter.
Yeah, yeah. Interesting. Boy, but you look at the oval chain ring and your brain wants to say that this matters. But it's also, and you've done these experiments and likewise I've done the running experiments. It is amazing how the brain will adjust to these subtle changes.
Yeah. Yeah. I mean, we're, yeah, I guess we're wired for symmetry somehow.
Ah,
Um,
interesting.
but I think,
Mhm.
as I said earlier, there's sort of a religious devotees to some people are really passionate about how wonderful the non-round chain rings are,
Mhm.
uh, and including the manufacturers. I got some really nasty emails from a guy at Absolute Black
Yeah.
when when that paper came out.
Yeah. Yeah.
Oh my God, I'm a horrible scientist according to him.
Oh
Um,
no. Well, and I guess this is good where the research that you do isn't sponsored by a company, so it's really
that's
objective,
right.
and that's
That's right.
good.
Oh yeah, I should point out I bought all the well, we had round chain rings, but I bought the Rotor and the OSIM at retail prices. So
Yeah, yeah.
no conflict anyway.
Yeah.
Um, yeah. And I guess it comes down to, why do some people like them, some people don't? I think it could be as simple as, that first day that you rode them, did you have a good day?
Mm-hmm. Mm-hmm.
Were you rested and feeling perky and maybe had some motivation, or were you tired and,
Mm-hmm.
oh God, these are awful? You
Yeah.
know, I think it could be as simple as that.
Interesting. So I guess in cycling and running, it's the same thing, probably just to a lesser degree, but there's so many equipment choices that you can play around with different gear ratios. We've talked about crank lengths before. We're talking about shape of the chain rings in the front. And obviously all the different bike components. How do you tell people to figure out what's going to work or not work for them?
Oh gosh, I'm really not at that level of interface.
Mm-hmm.
Um, I do speak at fitter conferences, but I don't do fitting.
Mm-hmm.
I interact with sports scientists, but I don't go and walk in with the coach and talk to. Well, not very often, but very very seldom actually.
Mm-hmm.
So yeah, what I try to tell people is there are things that matter and there are things that don't. And so, when we talked about crank length, for instance, we know crank length isn't going to affect your metabolic cost or your maximal power. And so because it doesn't matter, you can use any crank length you want.
Mm-hmm.
So what crank length should you want? Well, depends. And if one of your goals is to get aerodynamic, then you probably want a fairly short crank
Right.
so that you can get low. I guess if all you did was hill climbs, you might want something longer, but which just is essentially the same as having a smaller gear ratio. But
Mm-hmm.
yeah. Um, and then with the non-round rings, there's so many examples of, in fact, Bradley Wiggins is a good example.
Hmm.
He won Tour de France with non-round chain rings, and then quit using them and came back and won world championship time trial and hour record with round.
Hmm.
You know, since it doesn't matter, you can do whichever one you want.
Oh, interesting. All right, we're getting some questions on our live stream here. So
Okay.
let me get this first question from Brian. I think oval chain rings are slower due to chain drops. Distance between the chain and derailleur varies. When changing gears, I have to back off power on my ovals to prevent chain drop. Is that something that you've seen? Oh,
I
and
haven't, and we're not changing chain rings or changing gears in our lab.
mm,
So yeah, I can imagine that, because
hmm,
yeah, but yeah, so if that costs you, if you have to be really patient with your shift every so often, yeah, it's
hmm,
gonna cost you
hmm.
some power for sure.
Yeah, yeah, yeah. And Bob, he said, "Whoa, beat me to it." He had the same question. So, all right, that was good. Yeah. And so there is the practical side of chain rings, and now, I mean, a lot of cyclists are going to a single chain ring in the front instead of a dual or triple even.
Mhm.
Have you looked at any of the single speed? Have you done work with that, or is it?
No, not at all.
Hmm.
Uh, what when we almost everything we do in my lab, we do it isokinetically. So
Mm,
we're controlling the cadence.
yeah.
Um, so we're never changing gears.
Hmm.
Um, yeah, and and then the other thing we do is constant power. That's a different ergometer, but again, it's in one gear.
Hmm. Hmm. Oh, interesting. Yeah, no, it's and Brian's following up with it. You're supposed to have 1 to 2 millimeters between chain and derailleur. Brian has built his own bike, so he's looked at a lot of this. Impossible with ovals. So yeah,
Okay.
that's a little bit of a trick. Well, it's just interesting that you've got manufacturers that are obviously trying to sell a product, and they've you know and athletes just need to go through the process of trying to select and what works and what doesn't work. And I think the research that you do, this is what I really like about it, is that it really helps make some of those decisions, because at the end of the day, 172.5 crank versus 175, I don't need to spend the money, to try a different set of crank lengths. I know that I'm going to get the same output. So,
Yeah. And it's funny. I won't name them, but I was on a Zoom call last week with a very prestigious national team
hmm,
talking about crank length, and this is their sports scientist is absolutely top notch,
hmm,
and yeah, he wasn't aware of some of the research, so
hmm,
pretty interesting. That
yeah,
I read somewhere that it takes research at least 20 years to make it into the popular domain.
hmm,
And our original chainring paper came out. I mean, I'm sorry, crank length paper came out in 2000, so we're a little beyond that.
hmm,
And I guess it is starting to be adopted a little bit, but
yeah,
it's interesting. And with you're talking about running. Um, One of the cool things, studies that I've read about running gait, is actually from the guy, I can't think of his name. He's at BYU. You know who I'm talking about?
Ian Hunter.
Yes.
Yeah, yeah, Ian does some great work. Yeah,
Yeah.
yeah,
So he's got a great paper where they ran at their own self-selected stride rate,
yeah.
and then he gave them a metronome to make them run either higher cadence or lower cadence,
Hmm.
and in whether they were experienced or inexperienced, and whether they were going faster or slower, as soon as they deviated from their self-selected stride rate, their
Yeah.
cost went up
Yeah.
on both sides,
Hmm.
faster or slower.
Hmm.
And I think that's all about, well, you tell me that I think of that as it's all about matching your leg spring stiffness and the natural frequency of your spring and mass system.
Yeah, there's a lot of ideas in that, and U-shaped phenomena that you optimize running on minimum oxygen cost, or And I've done some work in that area too. And just a quick story, because these are just sort of fun stories to tell. When we've done that type of work, I'd put people on the treadmill and tell them, okay, you're going to run 10% faster stride rate. And you give them that metronome. And if you don't pay attention to them, and if you don't keep reminding them, they'll start at that 10%. And before you know it, they will be going back to their naturally selected stride rate. They will just gravitate. And so you have to sit there and you got to pound on the treadmill. No, this is the rate. This is the rate. Keep this rate. Keep this rate. And
Yeah.
it's amazing how attractive that preferred gait pattern really is. But what's also really interesting in this space, I did that experiment that you're referring to there, and I did it at different speeds. And my idea was that if you do this test where you have people run at different stride rates and the same speed, that oxygen cost tends to go up. So that U-shaped phenomena. But as you go faster, my idea was that, well, it would be more important. And so that U-shaped phenomena should get steeper, right? And so we did it at 3 different speeds, and lo and behold, it came out exactly opposite.
Oh, no.
As they got to the faster speed and they manipulated stride rate, plus or minus, I think we were doing 10 or 15%, VO2 in essence flatlined.
Oh, how about that?
And I'm like, what the heck? Well, here's the mistake I made. I was only looking at energetic cost from oxygen. And so I was only looking at VO2. And so in essence, what was happening is, especially as we were getting out these different stride rates, they were in essence getting to max each time. And so there was a ceiling effect in terms of how high VO2 could go up. And so I went one of these, oh, of course it flatlines. Of course it's going to get to a point where VO2 doesn't increase anymore because you're near
Right.
VO2 max. So, but if
Yeah.
I went back and if I do redo that study, I would include VCO2 and energetic cost, and then maybe I would see something a little bit different. But
Oh, well, good study to have queued up for next
yeah,
semester.
yeah. But it's just sort of fun how you start off, and even in talking about the chain rings, you start off thinking it's going to be one way. I mean, that's what we do, is we're making a hypothesis, and then we do the test, and it doesn't always pan out the way that we thought it was going to be.
Well, yeah, it's funny you say that because, I got started with chainring research. In my dissertation, I justified it because I was going to study the muscular power of kids versus
Hmm.
adults. And I couched it as, well, maybe the kids are using standard crank lengths, and so that's too long, and that's why they're less powerful and so forth.
Hmm.
And but the real reason, that's not the real reason. The real reason is that I was coaching Team EDS track cycling team,
Hmm.
and my training partner was on that, Trey Gannon, who was 5'8", but with long torso and
Hmm.
shorter legs. And then Nick Chenoweth, who was 6'5" or 6" with long legs. And so, they did what anybody else would do. Nick rode long cranks. He rode 167.5s.
Hmm.
And Trey rode short cranks. He rode 165s.
Hmm.
And so I just had it in my mind, this can't be optimal.
Right.
There must be, we need to do this research. And that's what got me started down the path. So
Oh, I love it. Well, and I, went down this path with running, and in essence, I was trying to answer the question, why do we run the way we run? Why is that preferred gait pattern such an attractor that you keep coming back to it regardless of, instructions to change gait? And, the U-shaped phenomena, the other part that's really interesting is you can look at rate of oxygen consumption plus or minus 5% of your stride rate, or maybe even 10%, and VO2 won't be maybe about 1 or 2 mLs per kg per minute different. And it may not even be statistically different. And so what I always say is, around that preferred gait, the VO2, there's some slop in the system that you can choose different gaits to end up with the same metabolic cost. So, and
mhm.
then it's just a trick of why are you choosing one gait over the other? Why are you doing like what in your cycling research? Why are they, inkling different when the chain rings are a different shape?
Yeah. And I guess I've always thought about running as, like I said, as being matching your stride rate to the natural frequency of your spring and mass system.
Hmm. Hmm.
And I actually have a funny story about that because as you may know, we in my lab, one of our techniques is eccentric cycling,
Mm-hmm.
where a motor drives the
Yep.
cranks backwards and you resist it,
Mm-hmm.
and incredibly effective at improving strength and hypertrophy. Also beyond description at making you sore.
Mm-hmm.
No matter what you've done stupid in your life in the gym, we can make you more sore in about
Yeah.
5 minutes.
Right.
But anyway, one winter I was doing a lot of that, and I one day I decided to run with one of my kids. We have a building with a hallway that goes all the way around in the basement. It's 5 laps to the mile,
Mm-hmm.
and you're in a small hallway, and just the instant that I started running, after doing all this eccentric cycling, which is known to increase leg spring stiffness,
Mm-hmm.
what I heard was tap, 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 tap.
Mm-hmm.
I didn't make any effort to take short, fast strides, but that's what my body chose to do immediately.
Yeah, I love that. And here's the funny thing is, if we go back to some of that work we were talking about on stride rate VO2, you're in essence increasing the metabolic cost of running by doing that, changing that stride rate like that.
Well, not my thought, and you're the running person, so correct me. I thought that you're always trying to match your natural frequency, and that's where the middle of that U
Right.
shape is.
Yeah, right. No, I love it. And yeah, this is where the fatigue model starts to come into play too, because I think the eccentric loading, that's the idea, is you're looking at this muscle that's not able to generate as much force. And so I think you're right that you're actually trying to reduce the load on the muscle by changing gait the way they're changing it.
Interesting take on it. I hadn't thought of it that way.
Yeah, I did. That was my doctoral dissertation. Actually, I did. I had people run on the treadmill, and I did, different measurements, mostly, this accelerometer work. And then I had them come off the treadmill, and I had them do repeated knee extension exercises. And I just kept going to failure. It'd go to failure. I'd say, okay, take a break. Okay, now do it again. And I'll do it again. I mean, they were destroyed.
Cool.
And
We've done something like that.
yeah. My idea was that I wanted them to, and I wanted to, in essence, take the quadriceps out of running. And if I could experimentally take it out, and then have them run without the quadriceps. That's really what I was shooting for. And they got back on, and they ran with the same gait at that point.
Huh.
Yeah, it was really interesting. So,
Wow. Yeah, we did a study like you're talking about with
mm,
go to failure, recover for whatever it was, 1 minute, go to failure again.
mm-hmm,
But we were doing it with single leg cycling.
mm,
So, you've got this concentrated oxygen delivery,
yeah,
which means you can take the lactates up beyond description.
mm-hmm,
And one of my grad students set the lab record for blood lactate,
mm.
20 millimoles,
Whoa!
and that's from one leg,
Oh
from
my
single
goodness!
leg cycling.
Yeah,
It was, yeah,
and that's high. That's like double what you would see at a max test. That's awesome.
yeah, close.
Uh,
So
uh.
anyway,
So it's interesting when we started the conversation, or maybe it was right before we even started streaming. You were talking about some different drive chains or different ways to design what the pedals were doing, or how to pedal a bike. What are your unique thoughts on how to make a bike go forward, I guess?
oh, right. Well, so what we were talking about is that, how I talked about during sprinting, you extend the extension phase or lengthen the extension phase.
Mm-hmm.
Well, animals do that as well. And I know I've written some more up in some of the papers, but the one that comes to mind is bird flight. So their wing beat down
Mm-hmm.
is longer and slower than the reset up.
Mm-hmm.
And by doing that, you increase, some people refer to this as duty cycle. Other people don't like that term, but the portion of the cycle that's spent doing work Uh, and so you can, if you can vary that, if you can make the muscle produce work all the time instead of, resetting,
Hmm.
then in theory, you can get more power out of it. Now, you may not be able to support it aerobically, so that's a different issue. But yeah, what I was saying is there have been two crank sets that do that. And right now I am struggling to remember the one from the 80s, but again, I have one in my lab. Oh God, why can't I think of that? I got it from Scott Dixon. So some of your listeners will know the name Scott Dixon,
Okay.
winner of Paris Brest Paris a couple of times.
Mm-hmm.
Um, and then the original rotor, which not the chain ring, but the crank set, which I don't think you'll see them on the market at all. There is one in my lab. We've never used it, but so what those do is they slow down your leg during extension, but then they make it flex really fast.
Mm-hmm.
Well, not really fast, but faster. So there are points in the cycle where, you'll have one leg almost fully extended and one leg that started extending, and then this one catches up and so forth. And so that does the same thing that I'm talking about with bird flight.
Mm-hmm.
And that should improve muscular power.
Mm-hmm.
So the same thing with rowing. Rowing it has a lot of tradition about how fast you should reset
Mm-hmm.
or return, I guess they call it. But if you actually put a little muscular power into it, you can reset really quickly, and you can be pulling a greater percentage of the time. And so one of the groups I'm working with, it's actually been really funny. So if there is tradition, if people are immersed in their tradition in cycling or triathlon, you ain't seen nothing until you've been in rowing.
Yeah.
There is no science that they will pay any attention to, as far as I can tell. And so there's a situation where this one athlete that one of my colleagues works with has been world champion. She wins, she crushes her competition mostly when the conditions are slow. So when they're going into the current or into a headwind.
Okay.
But when they're with a tailwind or down current, she doesn't crush. She will, she's still top few. But so what we wanted to do there was give her a longer oar, so a bigger gear ratio, because the implication is she does better at lower cadence compared to the other athletes. And I even offered to pay out of pocket. I will buy these oars but her coaches will not let her.
Huh.
And and you can't test it either. You can't test it on an ergometer because, like on the Concept 2 ergometers, I'm sorry, I'm going way off topic here.
No, that's right.
Okay. On Concept 2 rowing ergometer, if the way you change the resistance, you open up the fan, but when you do that, it doesn't mimic a larger gear. It mimics a slower boat.
Mm-hmm.
It just slows down more within each reset.
Mm-hmm.
And so the only way that you can simulate a longer oar is with a different cog inside the mechanism.
Mm-hmm.
And so I spent some time on the phone with Concept 2, and I found out what kind of chain and cogs they use. And the standard one for a Concept 2 is a 14 tooth. And so I ordered a 12 tooth, and I drilled and tapped it to fit on the spindle. And I've sent it to this athlete, sports scientist, unnamed, and we will find out if it works probably in October when he or she is done traveling.
Oh,
I
interesting.
already said she, probably. Oh well.
No, I think this is very much on topic, and maybe the broader topic is ways to develop propulsion. And in essence, that's what you want on a bike. That's what you want in flight or running or rowing. So I think it is all connected.
In fact, in running, correct me if I'm wrong, but I've seen some talks where they talk about why is turnover slower when you heel strike?
Hmm.
And the graphic that I remember was if you draw a line from center of mass through the heel under the ground,
Hmm.
and then later you draw a line from ball of the foot or the toe where they're toeing off.
Hmm.
If you draw that line, it actually intersects way under the ground.
Right, right.
So you actually have a longer leg,
Yeah,
effectively longer leg
yeah,
when you
yeah.
heel strike. Can you
Hmm.
comment on that?
Yeah, well, this is an interesting area, and this is the challenge of building shoes that return energy, is because especially if you're a heel striker, you're striking the shoe in one area of the shoe in one
Oh,
particular direction, and then to add propulsion, you actually need to redirect that force to be applied at a different part of the foot, at a different part of the shoe, in a different direction. So it's very complicated, but it is, yeah, I don't, off the top of my head, I'm trying to think of a study that compared cadence for forefoot strikers, midfoot strikers, and heel strikers. I'm drawing a blank right now. My brain isn't working too good, but
sorry about
yeah, it is an interesting area. But I'll tell you, a lot of the research that has been done is it's very difficult to get people to change their gait. If they are heel strikers, they will be heel strikers, and
that.
it's not always easy to get them to change to midfoot or even more so to forefoot. So it takes a bit of work. So
Well, we're talking about strides and running technique and all that. And I don't, if I know I had this conversation recently, but I don't think it was in one of our conversations. A buddy of mine back in way back 100 years ago, was a 32-minute 10K runner.
nice.
And I mean, pretty fast, right?
Yeah.
And so I went down to watch him run the Capital 10K in Austin. And I went to about the 4 or 5 mile marker, rode down there on my bike,
Hmm.
making sure that I'm in plenty of time to be there before him and get pictures.
Hmm.
And what I see is really kind of very confusing to me
Hmm.
because I'm seeing guys come through that just have the most awkward looking strides,
Right.
the worst
Hmm.
running technique I can imagine.
Hmm.
And I'm looking at my watch. What the hell did I screw this up? What?
Right.
Where's Barry? You
Yeah.
know,
Right.
and so a bunch of these big,
Yeah.
horrible technique guys go by. And a little while later, here comes Barry. And yes, he's still running 32 minutes.
Yeah.
So what we think of as an awkward looking
Yeah.
stride, yeah, don't change it.
No, that's right. It is, there's a lot of uniqueness to strides. And I'm even thinking in the triathlon world, there's a professional triathlete, Lionel Sanders, that has a very unique style of gait, and it works for him. You would not train someone to run that way because people are built differently than him or have different different structures built, and so it's really different experiences as well. So there is a lot of individuality. I mean, when you take a big picture, and this is the same with cycling, everyone cycles the same. They go round and round on the pedals. But when you start looking at that micro level of what's going on at the hip, knee, and ankle, well, now that tells really much deeper story. So circle back. Let's circle back to chain rings, and this is interesting. How the pitch in the beginning, or the answer in the beginning, is pretty simple. The chain ring shape didn't make a difference in terms of metabolic cost or even power that's generated.
That's right. Yeah. So, if you're on them, you don't have to sell them and buy round
Yeah,
ones.
yeah.
But if you're on round ones, there's no reason to buy, what do chain rings cost? The fancy chain rings, they got to cost a couple $100 now,
I would
right?
think so. Yeah, I would think
Yeah.
so.
So, spend that on, I don't know,
Uh,
nice dinner out with you and your
Yeah,
partner.
yeah, yeah. Well, I love it. And, people are always searching for that marginal gain and, to just improve performance just a little bit. This is great to just talk with you about this. And I think this is consistent with the theme that crank length didn't matter and shape of the oval rings didn't matter. The brain figures out how to bike and generate power.
That's right. That's right. Yeah, what does matter is training and
Hmm.
aerodynamics
Yep.
and maybe weight. And yeah,
Hmm.
it's sadly, there's no shortcut.
Yeah, that's true. Awesome. Well, Jim, thanks so much. This is excellent to have you on as a guest co-host again. And boy, hopefully that we'll get Ted back soon. And again, I hope he's doing well.
Yeah, yeah, I hope so too. And thanks for having me on. I'm glad I can fill in.
Awesome. Okay, talk again soon.
Okay, see you.